Welcome back to Spring Into Math 8. I'm Mr. Burns. Today's lesson topic is equations of a line using similar triangles. Let's go ahead and dive right into some examples. Here it asks us, write an equation for the line. Now this is a little confusing because we see here that we have our line graphed in black, and then I've already created some triangles here, and they're highlighted in red and yellow. So we're going to use what we see here to help us write the equation for this line. Okay, first let's see if we can figure out what the slope is together here on our graph. So I'm going to start down at the dot here on the bottom, the very far left-hand corner. Now I'm going to count up 2 units and over to the right 3. And now I'm at the red dot in the middle of the screen, which is actually crossing the y-axis. And again, I'm going to count up 2 units and over 3 to the right. So I've done that twice now, creating 2 different triangles. So we're going to go ahead and remember that the slope of this particular line is 2 over 3. Now, we need to figure out what is the b part of our y equals mx plus b equation. And we need to figure out the b, which is the y-intercept where it crosses. So you can see here that it's the middle red dot. And I have to count down 1, 2, 3, 4 spots. Okay, so my y-intercept is -4, and my slope is positive 2/3. Let's go ahead and write that equation here on this new screen. Y equals 2/3 x minus 4. Okay, so now we can see, based on the graph, we were able to pull some information out of it and write ourselves an equation. Our equation, again, is y equals 2/3 x minus 4. Okay, let's try another one together. Here we go. Write an equation for the line. We have a couple options here on how we're going to tackle this problem. The first one would be to use the slope-intercept form to find the slope, which would be y2 minus y1 over x2 minus x1. You can do that if you'd like, because we have 2 coordinates listed here. The first coordinate listed is -2, 3. And the other coordinate listed here is 2, -2. If you would like to insert those coordinate information into the formula to find the slope, go ahead and do so. Okay, I'm not going to do it that way, but if that's a way you like to do it, go for it. So let's collect a little bit of information here. Up at the top coordinate, -2, 3, that is a spot where the line of this graph crosses exactly in the corner of a box. And that's what we're looking for. And same thing with our other set of coordinates down at the bottom, 2, -2. Those are the places where it crosses exactly. So up at the top of the screen, I'm going to go ahead and count down. And I'm going to count down 1, 2, 3, 4, 5 units, and over 4 units to the right. That is actually our slope. Now, we would have gotten the same exact answer if we plugged in our coordinates to the slope-intercept form, which is, again, that y2 minus y1 over x2 minus x1. But I saved us a little time by just counting and using the information based on the graph. So hold on to that slope value, which is -5 over 4. Now we need to figure out where is it that the line crosses the y-axis. Now in this case, we do not see that it clearly crosses in a box. But what we can do is it crosses actually at halfway between 0 and 1 on the y-axis. So we can go ahead and say that our y-intercept is half, or 0.5. So let's go ahead and write that equation out. We have y equals -5 over 4. That's our slope. And our y-intercept is 1/2. Or you could choose to write the decimal 0.5. Okay, that's it for today, folks. If you need to watch it again, go for it. If not, good luck studying.